Okay, OTCO Chapter 11. This one will be relatively short. Let's go ahead and talk about sludge. So what is sludge? When we're talking about sludge, in this context, we're talking about the solid material that has been removed from the treatment process through sedimentation, basically the stuff that sinks to the bottom of a clarifier. Primary or raw sludge would be the portion of the total suspended solids that sinks to the bottom of the primary clarifier and is removed from the primary clarifier. Raw or primary sludge settled by itself in a primary clarifier can be anywhere from 2 to 7 or 8% solids, depending on how the clarifier is operated. When we talk about secondary sludge, we're talking about usually excess biomass, those microorganisms that we use in the treatment process. Of course, when we get too many of them, we need to remove some. In the waste activated sludge, or in the activated sludge process, we'd be talking about waste activated sludge. If we're talking about trickling filters or rotating biological contactors, we're talking about sludge that mainly consists of the sloughings off the trickling filter or the RBC. When we're talking about ponds and lagoons, sludge is probably going to be the stuff that's anaerobically digested at the bottom of the pond that has to be removed periodically. Chemical sludges may include stuff like, for example, at our plant we add ferrous chloride to remove phosphorus, which ultimately causes it to precipitate out or settle to the bottom of our final clarifiers along with activated sludge. So it's just sludgy material. This is solid material. Although we call it solid material, it is mostly water, but solid material that we have to get rid of. So sludge. Getting rid of sludge costs money. I always like to say in this class that getting rid of water is relatively free, basically. As long as it meets our permit requirements, we can dump it right in the river. It doesn't cost us anything to get rid of. Solid material, on the other hand, has got to be, at least in our case at Perrysburg, it's got to be trucked away. And then we have to find a place to dispose of it. So there's a cost associated with it. Untreated sludge, so sludge that's not been processed any further, your options for that generally are going to be incineration, which you see at a lot of larger plants. Cincinnati, Cleveland. I know they have incinerators where they take the solid material and they just burn it, and they still have to haul away the ash, but they'll incinerate it to reduce it, the amount substantially. Untreated sludge can be dewatered and disposed of in a sanitary landfill. That's fairly common. I know, for example, Wauseon, I believe Findlay, possibly City of Oregon around here. Those are places that haul their sludge to a landfill, generally after dewatering it, so that again, the water we can get rid of for free. So trying to remove as much water as possible from that sludge before we truck it somewhere is going to save us money. You can also take it off-site to be treated somewhere else. For example, at our plant, we do treat waste activated sludge from smaller plants around us like Haskins, Pemberville. We've had sludge from Grand Rapids brought to us in the past. So you do have that option to haul it to another location to be treated somewhere else, either at another wastewater treatment plant, or there are companies here in Ohio that accept sludge and use it to generate energy. So there is a cost associated with that. They do charge you to dispose of your sludge, but then they will take that and turn around and try to turn it into energy, which I guess we'll discuss a little bit more uh, as far as converting sludge into energy when we talk about anaerobic digestion in the next chapter. Digested sludge. So this is sludge that has been treated and stabilized to allow for beneficial reuse that can be treated either through anaerobic digestion, aerobic digestion. There are a few variations of those processes also. Uh, Autothermic aerobic digestion is something they do in Bowling Green and now in Fremont, where it's an aerobic digestion, but they also heat the sludge. Basically, what we're doing there is trying to stabilize the sludge so that we can haul it away and apply it on farm fields, stuff like that. So cheaper than hauling it to the landfill, but in order to get it treated to an extent that we can do that, we have to process it a little bit further. So this chapter talks a little bit about thickening sludge, and the whole concept behind thickening sludge is we're trying to reduce the volume, basically trying to remove the water, which again we can dispose of for free, and take that solid material and concentrate it. Uh, if let's say in our gravity thickener, if we can take a 2% sludge and concentrate it to 4%, we've reduced the volume of sludge that we have to treat further by 50%. So a few different technologies that can thicken sludge that are mentioned uh, in the chapter. Gravity thickening. We have a gravity thickener at the Perrysburg plant. It looks and operates very similar to a primary clarifier. The floor of our gravity thickener is sloped quite a bit more than our clarifiers, and the rotating mechanism that collects sludge at the bottom has pickets, or basically pipes, that stick straight up in the air and try to create voids in that sludge blanket to allow water to escape. So gravity thickening, a gravity belt thickener, going to look similar to a belt filter press. Generally, with these, you're going to be adding polymer to the sludge, which will kind of get it to clump together. Uh, and and then there will be little plastic pieces that kind of scrape across the top of the belt and create voids in the sludge, again to kind of allow water to drain. So gravity belt thickener is again similar to a belt filter press. You've got a porous belt with water draining through the bottom. Dissolved air flotation is something that they had at the Toledo plant at one time. I don't know if they still do that, but basically you're taking a very thin sludge, like say waste activated sludge, and you're putting diffused air in the bottom of a tank, and as the air bubbles rise to the top, they capture these sludge particles and attach to them and lift them to the top uh, of the tank, and where you have a skimmer or some sort of sludge collector that kind of pushes that sludge to the end of the tank where it can be collected. And then finally, the last piece of equipment I think mentioned in the textbook is a centrifuge that basically spins at a high rate of speed and more or less spins the excess water out. I describe it as kind of similar to the spin cycle on a washing machine using a centrifugal force to kind of spin the water out of the sludge. So some of the technologies that we use, again, our primary concern here is taking sludge that, again, is most of the time going to be over 90% water and trying to concentrate it um, so that it's got a lot less water and more higher percent solids. So our last picture here is a picture of a sludge drying bed. So again, this would be something where you would take sludge and use nature, both gravity and sunlight. Most of the time, your sludge drying beds are actually going to be used to dewater digested sludge, but raw sludge on a sludge drying bed would probably be pretty odorous. But the concept is the same. And the main takeaway from this chapter is to remember that disposing of water at a wastewater treatment plant, when you have an NPDES permit and you're allowed to discharge it to a receiving water, a stream or a river, disposing of the water is free. Having to dispose of the solid material costs money. So there you go. Chapter 11. When we get into chapter 12 and chapter 13, we'll be talking a little bit more about taking the sludge and processing it so that we can dispose of it in a more cost-effective way.